Hey, grade 10s, Mr. McLeod here with our penultimate lesson of the year. And this one's going to involve something called sine law. So we saw that our primary trig ratios, the sine, cos, and tan, work really well in right triangles. But what if you don't have a right triangle like this triangle? It's not a right triangle. So what can we do? Well, we could divide this triangle into two right triangles by making a vertical line from the top angle there. And I'm going to call this red line H, just because it kind of looks like the height of the triangle. This example, we are trying to find this length of this side, which is B. And we're given the angle A, and we're given the angle B, and we're given the length of this side. I'm going to label this side as side lowercase a. So here's a good guideline, is that angles are labeled with capital letters, and then their opposite sides are labeled as the same letter but lowercase, and you'll see why, I think, in a little while. Okay, so I'm going to just do this in a general way so that you kind of get the relationship I'm trying to show you here. So this angle B is 82 degrees. Theoretically, I could find this length of this H by using the sine ratio and then this side A. So sine of angle B would be the opposite side, H in this case, over B's hypotenuse, which is A. And then we could solve for H, so put sine B over 1, H times 1 is H, and then we have A times sine B. And then we could do the same thing with the other side, or the other angle, angle A. Angle A is 64. Its opposite side is also H, and then its hypotenuse would be this side here, B. So we could say sine A is equal to H over, whoops, H over B. And then again, we could solve for H. H times 1 is H. And then the other side is B times sine A. Okay, now here's something that's interesting. H is equal to A sine B, and H is equal to B sine A. So if H is equal to this and H is equal to that, then A sine B must be equal to B sine A. A sine B must be equal to B sine A. And there you have a relationship that involves just the sides and the angles of this non-right triangle. So we've kind of skipped past even having to calculate H. So this is a neat relationship. We have A sine B equals B sine A. However, we're used to seeing this expressed with both letters on the same side of the equation. So I'm just going to do a little rearrange here. I'm going to divide both sides by sine A times sine B. Sine A times sine B. And then you see on this left side, the sine B's are going to cancel. And on the right side, the sine A's are going to cancel. So what you're left with is A over sine A equals B over sine B. And this is what we call the sine law. Okay, here's the sine law expressed in the formal way that you usually see it. We have all three sides with their opposite angles as ratios. So you can either put the side lengths, the small letters, on top, and then the signs of the angles on the bottom of each ratio. Or you could flip it, and you can put the signs of the angles on top and the side lengths on the bottom. Doesn't matter which way you prefer. Generally, I like to put the little letters on top and then go from there. But it doesn't matter. It's up to you. Okay, so let me show you how to use the sine law to find a missing angle. Now, what we could do is we could label our triangle since we need the A, B, and C. So I could call this A, and then B, C. If I label this angle A over here, then this side automatically has to be lowercase a. And then if I label this angle B, then this side has to be B. That's just the relationship. And why we do that is because in triangles, there's kind of a neat property where the longest side is always opposite the biggest angle, and the smallest side is always opposite the smallest angle, and vice versa. So it's this relationship that allows us to calculate these unknown sides and angles. All right, one thing I like to do is just to make this point even more clear, is to kind of connect the angle with its opposite side length measure. And this makes it really clear and easy to set up when you're doing these calculations. Okay, so how we set this up is this: we have this side A over the sine of angle A. So we have A over sine A is equal to B over sine B. All right, now we fill in what we know. So A is 27 sine theta is equal to, the length of side B is 32 over sine 73 degrees. Okay, so now we have two fractions equal to each other with one unknown. Maybe by now you're getting used to this method of solving, which is cross multiplying. So we have 32 times sine theta. 32 times sine theta equals 27 times sine 73. And we want to get sine theta by itself, so we divide both sides by 32. So sine theta equals 27 times sine 73 degrees over 32. Now don't forget to find the angle. You have to do the inverse sine. So sine to the negative 1 of this calculation. Okay, so in your calculator, you're going to punch in 27 times sine 73, hit equals, and then divide by 32. And then you hit, at the end, second function sine to figure out the angle. So you should practice doing this calculation right now. Okay, so I got about 54 degrees. If we round up to the nearest angle, nearest degree. All right, and that should make sense because the side opposite our angle A is a little bit smaller than the side opposite our angle B. So then we would expect its opposite angle to be a little bit smaller than B. So 73 degrees compared to 54. Okay, in this example, we're going to find the length of a missing side. And one thing I like to do is just set up that each side with its opposite angle. Draw a circle around and then connect it with this line. And it makes your calculation really easy to set up. And so I refer to these as dumbbells because they kind of look like the dumbbells from the old cartoons. All right, now we know the length of this side, so we have to connect it with its opposite angle. Whoops, we don't know this angle. Is there a way that we can fill in this side of the dumbbell? Well, if we're given the other two angles in the triangle, of course we know that all three angles have to add up to 180 degrees. So all we have to do is subtract these two angles from 180 degrees. Okay, it's 88 degrees for this angle here. And so you can see that anytime we're given two angles in a triangle, we can always find the third angle and use this sine law. All right, now these dumbbells help you to set up calculation in a really simple way. We have each dumbbell is going to represent one side of the equation. So I like to put the side on top. So I have 27 divided by sine 88 degrees. And don't forget, it's the sine of the angle, not just the angle number itself, but it has to be the sine of the angle. And on the other side is x over sine 38 degrees. Okay, and of course we just cross multiply in order to solve for x. So we have x times sine 88 degrees is equal to 27 sine 38 degrees. And to get x by itself, we just divide both sides by sine 88 degrees. Now in your calculator, you're going to punch in 27 times sine 38 degrees. Hit equals. That's important. So you do the top of the calculation, hit equals. Don't clear it, just leave that answer there in your calculator, and then hit divide by sine 88 degrees, and you'll get your answer. And the answer is about 16.6 centimeters. And that's about what we expect since um, our opposite angle, 38 degrees, is so much smaller than the other opposite angle, which is 88. So I would expect this side to be shorter than this side. All right, that's it for now. Sine law is pretty simple to use with a little bit of practice. You just set up your calculations the same way every time and then cross multiply to solve. So good luck. Let me know if you have any troubles, and bye for now.